So, what really goes into making a road? I mean, you might think a simple dirt path is just a path, right? A track worn down over time. But the truth is, even the most basic road is the result of a whole lot of deliberate choices. Every single road, from a tiny country lane to a massive superhighway, tells a story that's written right onto the landscape. And that story has a hidden logic that we're about to uncover. Just look at this road in Bolivia. It almost seems to defy logic, just clinging to the side of a mountain like that. But, it's not random at all. There's a hidden system here, a really precise logic that governs every single turn and every single slope. So the question is, what is that logic? And how in the world does it turn an impossible mountain into a vital pathway? Well, the answer lies in something called the hidden geometry of roads. It's this field that's both an art and a science, and it's been quietly shaping our entire world. It's connecting communities and making modern life possible, often in ways we don't even see. Yeah, behind what looks like chaotic switchbacks, there's a totally rational system. And we're going to pull back the curtain on that system by looking at this fascinating document from 1978 that, well, it literally wrote the book on how to do this. The key that unlocks this whole mystery is a term: geometric design. And our guide for this is going to be a foundational text that was published way back in 1978 by the Transportation Research Board. Its whole purpose was to standardize the rules for building some of the world's most essential, low-cost roads. At its very core, geometric design is, and I quote, "the art and science of shaping a road." What does that mean? It means it's not just about paving a line from point A to B. Oh no. It's about thoughtfully calculating the curves, the slopes, the width, the actual geometry that makes a road not just functional, but, and this is crucial, safe. But here's the thing. It's not a rigid, exact science. The engineers who wrote this guide, they knew that every single landscape is different. Their real genius was realizing that you could standardize the thinking behind road design. They created a framework that balances these universal principles with the reality you find on the ground. So, what are those on-the-ground realities? Well, the guide explains that engineers are basically in a constant balancing act with 4 different levers. And every road you've ever driven on is the result of how they manage these 4 crucial factors. And here they are. First, you've got the physical realities. How much traffic is this road going to carry, and what's the terrain like? Then you have the project's goals and constraints. What kind of quality of service are you shooting for? And of course, what's the available cost? Let's break each of those down. Okay, let's start with traffic. When this guide talks about low volume, it really, really means low volume. I mean, get this. Some of these roads were designed for as few as 5 to 10 vehicles per day. That tiny number completely changes the entire equation for what kind of road you even need to build. The guide actually breaks it down into 2 main classes. So Class 1 roads, those with fewer than 50 cars a day, are often just graded earth, what you and I would just call a dirt road. Class 2 roads, they handle a bit more traffic, so they get a surface like gravel. The design is directly tied to how much traffic they expected from day one. Next up is the terrain. You can think of it as the canvas the road is built on. Is it flat? Is it rolling? Or is it mountainous, like that crazy road in Bolivia we saw? An engineer has to learn how to read the landscape because the terrain dictates pretty much everything else, especially the cost and just how hard it's going to be to build. The third lever is quality of service. And this is about way more than just how fast you can go. It's really a measure of the total driver experience. Is the road safe? Are the hills manageable? Is it a comfortable drive? And really important, is it economical for the vehicles that have to use it every day? And finally, we have cost. This is the great equalizer, right? The funding you have determines all the trade-offs you're forced to make. You might want a high-quality road that just plows straight through a mountain, but the cost is going to force you to build a winding, slower road around it instead. Every road is basically a balance sheet of these 4 levers. So, why? Why did a group of engineers feel it was so critical to write all this down back in 1978? What was going on in the world that made this knowledge so urgent? This is where the story gets really, really interesting. See, in the 1970s, there was this massive global push for development, especially in rural areas. And at the very heart of that push was a simple, universal need: roads. I mean, think about it. You can't develop agriculture, get food to markets, provide healthcare, or get kids to school without a reliable way to get from here to there. Roads were, and they still are, the arteries of a functioning society. So, in October 1977, the Transportation Research Board kicked off a project to gather up all the existing, scattered information on how to build these crucial, low volume roads. Their goal was simple: create a single, accessible resource. And just 1 year later, this compendium was born. This quote from the book's introduction really gets to the heart of why this was so important. It says the technology was undocumented and exists in the minds of those who have applied it through necessity. This knowledge wasn't in textbooks. It was in the heads of engineers out in the field. This book was this huge effort to capture all that hard-won wisdom before it could just disappear. So what's the legacy of this simple book of standards? Well, it's this profound understanding that every road we travel on is so much more than just asphalt or gravel. Every single one of them tells a story. This cover, right here, it represents the culmination of that whole global effort. I know, it might look like a dry, technical manual, but it was actually a playbook that helped connect countless communities all over the world. In a very real way, it democratized the knowledge needed to build the most fundamental pieces of our infrastructure. And that's what it all comes down to. Roads are not random. They are carefully crafted solutions to a really complex puzzle. Every single curve and every single slope tells a story of engineers balancing traffic with terrain and quality with cost. It is a hidden logic, and it's all around us. Which leaves us with a final thought. The logic of the low-cost road is just one of these invisible systems that design our world. So the next time you're on a journey, maybe look down at the road beneath you and ask yourself, what choices were made here? What story is this road telling? Because once you start looking, you'll start to realize these invisible designs are absolutely everywhere.